Hello, welcome to today's lesson on section 5.6, which is finding rational zeros. So today I'm getting kind of fancy on everyone, using a PowerPoint here. So we'll start with the first slide. The first slide obviously shows the title, section 5.6, finding rational zeros. Let's move on to the next slide, which is the rational zero theorem. So instead of me writing this out, it might be better if I have this typed up so it's easier to read. So let's say f of x is a polynomial. So this right here is a polynomial. A sub n, that's a subscript by the way for the n, is the leading coefficient. And then here a0 is the constant term. So the rational zero theorem states the following. If you have a polynomial function with integer coefficients, means your coefficients are not fractions or decimals, just integers, like -2 or 5 or whatever, then every rational zero of f has the following form. We call this p over q, or the factor of the constant term divided by a factor of the leading coefficient. This will seem a little confusing, but bear with me when we get to example, it'll make sense. But before we move on to example, just remember a rational number is any number that can be expressed. See how messy my handwriting is? Sorry about that. It can be expressed as a ratio of two integers. So any number that can be expressed as a ratio of two integers. And that makes sense because if the constant term is going to be an integer and the leading coefficient is going to be an integer, factors of them will be integers as well. So this right here would be a rational number. So let's look at an example here. You're asked to list all possible rational zeros of the following function. So here's what I do. We find what p is. We find what q is. Now p is going to be all the factors of your constant term, right? That's my constant term. So all the factors of that are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, or plus or minus 12. Let me erase that right there. And you have to put plus or minus because obviously 12 can be divided by positive or negative numbers. Now q is all the factors of your leading coefficient. Now in this case, the leading coefficient is 1 because you don't see a number there. So that's just plus or minus 1. So when you want to list all the possible rational zeros, which is of the form p over q, all the possible rational zeros will be right over here. It's just basically going to be all these numbers divided by this. And anything divided by 1 is itself, so basically it's going to be plus or minus 1, comma, plus or minus 2, comma, plus or minus 3, comma, plus or minus 4, comma, plus or minus 6, comma, plus or minus 12, divided by plus or minus 1. Or plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. So any one of these numbers here can be a zero. Doesn't have to be. They can be zeros. But doesn't have to be. That's what's meant by possible. Now you're asked to find all real zeros of f of x. Okay, this is going to be a little tricky. I'm going to go to OneNote here. So the next thing I'm doing, which I'll circle in blue, or light blue, or baby blue, whatever you want to call that. So now how do I find all the real zeros? This is going to be a little bit tricky. So let me create a new OneNote here. So again, our problem is the following. f of x equals x cubed plus 2x squared minus 11x plus 12. Notice that you can't do factor by grouping. If you did, and don't write this down, but if you did, you first would have to do this. You factor out an x squared, you get x plus 2. Really can't factor anything out of here. And notice that these are not the same. So that wouldn't have worked for us. So factor by grouping doesn't work here. So instead, what we do is we test the rational zeros. So let's first use synthetic division, as I mentioned here, or synthetic substitution. Because if you remember from the factor theorem, if you get 0 as a remainder, then you know that number is a 0. So let's work this out.
Doing a recording. You just want to hang tight.
So let's try 1. Because notice how we saw 1 as a possible 0, right? So if I test it, I do 1, 1, 3, 3, negative 8, 4. Okay, that doesn't work. Because we need 0 at the end for this to be a 0. So that's no good. Let's try negative 1. 1, 2, negative 11, and 12. 1, negative 1, 1. Negative 1, negative 12. Bingo. Actually, no, never mind. That doesn't work. Because you have 1, negative 1. We were so close. So that's 24. So we will try again. Let's try 2. So 1, 2, negative 11, and 12. So 1, 2 times 1 is 2. You get 4. You get 8. Negative 3. Negative 6, 6. Again, no good. Let's try negative 2. 1, negative 2, 0, 0. That's going to be negative 11, 22, 34. Okay, still doesn't work. Let's try 3. 1, 3, 5, 15, 4. Okay, this is getting a little frustrating. So it's 12, doesn't work. Let's try negative 3. 1, negative 3, negative 1. So I'm starting to become pretty skeptical about this problem. Let me actually get my calculator out to see what will work for this. Okay, so apparently we would have to try negative 5. So 1, 2, negative 11, and 12. So you go 1 down, negative 5. You got negative 3. 15, 4. No, that doesn't work either. Okay. So this is a kind of an epic fail here. Yeah, so apparently no rational zeros work. I totally apologize about that. Let's try another one. Okay, this one might be a little bit better for us to try. So Actually, I take it back. That's a horrible one to try. Let's try this again. Find all real zeros for f of x equals x cubed minus 8x squared plus 11x plus 20. Okay. First of all, we got to say all the possible rational zeros. So all the factors of 20 are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, plus or minus 20. And of course, q being all the factors of the leading coefficient, that's just 1. So I know that 1's going to work, because obviously when I divide everything by 1, I have this. So if I test 1 out, 1, negative 8, 11, 20. God, today is just not my day. Okay, that doesn't work. Let's try negative 1. Negative 1, negative 9. Thank goodness. We found that worked. So negative 1's a 0, because the remainder is 0. And that's part of the factor theorem that we talked about yesterday. Now this right here is x squared minus 9x plus 20. If you set that equals 0 and factor it, so that's the beauty about synthetic substitution. You can now get something that's easy to factor. So you get this. So x equals 4 or 5. And so those would be your real zeros. You can also graph it to see for yourself, and you'll see it crossing the x-axis those places. So I think the key thing here, and maybe it's kind of a blessing in disguise that that I went through all this trouble here, is that this only gives you the p over q thing. Yeah, the p over q thing right here. It only gives you possible zeros. So there's a good chance none of them might work. If I'm having a bad day when I write the test, I could do that to you guys, but I probably won't because I'm a nice guy. So yeah, that's how that works. Let's try one more, and then I think you guys have enough to do the classwork on Friday. And by the way, I won't be here on Friday. I'll be gone for the freshman retreat, so you'll have a sub. So just make sure you be good to your sub. Okay, let's try one more for fun. What's good to do? Let's try number 18 here. This is number 18 from the book, by the way. So number 18 from page 374. You're asked to find all real zeros for f of x equals x4 minus 16x squared minus 40x minus 25. Okay. So all the factors of 25 are the following. All factors of the leading coefficient are just this. Now I could give you a problem with the leading coefficient that's not 1, like 2 or 3. I'll probably put 1 or 2 of those in the class. We'll just see how that goes for you. Because that means you may have a fraction as one of your rational exponents. So anyway, let's try this out. 1, you got to put 0. Why do I put 0 there? That's because you don't have an x cubed term. So make sure you don't forget that. So let's test 1 out. 1, 1, 1, 1, negative 15, negative 15, negative 55. No bueno. Doesn't work. I don't like it. Let's try negative 1. And you're going to see me get very, very agitated if I have to do this over and over again. So we do 1, negative 1, negative 1, 1, negative 15, 15, negative 25, 25. Cool, that works. So negative 1's a 0. By the way, just because negative 1 works, negative 1 can work a second time. Adjust it.
I'll be done in about 5 minutes.
Okay. So negative 1 can work a second time. Now in this case we have x cubed minus x squared minus 15x minus 25. Remember, you always want to go one exponent down for your quotient, because we had x4 originally. And when you do this with x up to -1, it's like dividing by x plus 1. So if you think about x4 over x, it's like x cubed. Now we can't do factor by grouping. Factor by grouping would not work if you tried it out. And the only way it tells it try it out would not work. So do synthetic substitution again. And for this, the p over q's are still the same. Plus or minus 1, plus or minus 5, plus or minus 25, plus or minus 1. So you put 1, -1, -15, and -25. Now, I'm not going to try 1. Since it didn't work earlier. If it didn't work earlier, why would it work now? But let's try -1 because it could work twice. 1, -1, -2, 2, -13, 13. Okay, forget about that one. So let's try 5. 1, 5, 4, 20, 5, 25. Cool, that works. So 5 is also one of our zeros. Now this right here is x squared plus 4x plus 5. This is not factorable. So let's use quad form. If you quad form this, you get the following. X equals -4 plus or minus b squared minus 4ac divided by 2a. So x would equal -4 plus or minus square root of -4 over 2. Now, you're only being asked to find all real zeros. This is not real. Since that's negative. So basically you're done. The answer is -1 and 5. Are the real zeros. But just for fun, if we work this out, you get -4 plus or minus 2i over 2, which would be -2 plus or minus I. We will look at this when we get to, I think, 5, 7. But notice how we have 4 answers. 2 real and 2 imaginary. And notice how the degree is 4. This is kind of a good segue to what we're going to do on Monday for the classwork, or the video you're going to watch over the weekend, so you can be ready for the classwork on Monday. Something that's called the fundamental theorem of algebra, which states that the number of real and non-real zeros will always equal the degree of the function. But in this case, our only real zeros are -1 and 5. Okay, so I'm done with the video. Sorry for making it kind of long and not carefully planning out the first problem, but maybe that was kind of good. You saw that how you may not get an answer, even if you find all the rational zeros, none of them could work. Alright, I'll see you guys later.